it's Chris Kresser. Welcome to another episode of Revolution Health Radio. This week, I'm happy to welcome Dr. Dale Bredesen. Dr. Bredesen is an internationally recognized expert in the mechanisms of neurodegenerative diseases such as Alzheimer's disease. He graduated from Caltech, then earned his MD from Duke University Medical Center. He served as chief resident in neurology at the University of California, San Francisco, before joining Nobel laureate Stanley Prusner's laboratory at UCSF as an NIH postdoc. He held faculty positions at UCSF, UCLA, and the University of California, San Diego. Dr. Bredesen directed the program on aging at the Burnham Institute before coming to the Buck Institute in 1998 as its founding president and CEO. I met Dr. Bredesen at a functional forum event where I gave the keynote back in April, and we had a fascinating chat before my talk on a functional and ancestral or evolutionary approach to diagnosing and treating Alzheimer's disease. And I was really excited by our conversation, and I asked Dr. Bredesen if he'd be willing to join me on my podcast to talk about it, which he was. So without further ado, let's jump in. Hey everyone, if you're like most people I know, you don't have the time or the desire or training for that matter to sift through the hundreds of medical studies that are published each month. But whether you're struggling with a chronic health problem or just want to maintain your health and live as long as possible, it's important to stay informed about the latest research and how it might affect your well-being. And let's face it, it's easy to get overwhelmed by all the conflicting stories in the media. You need a source of unbiased information that you can rely on. One that's easy to understand without too much jargon and full of practical tips that you can put into action. That's where my website, chriskresser.com, comes in. You'll find in-depth, evidence-based articles on a wide range of health and nutrition topics each week. You'll also find over 10 free ebooks on subjects like effortless weight loss, healing your gut, thyroid disorders, and natural skincare, as well as online classes and programs on optimizing nutrition for fertility and pregnancy and lowering your cholesterol without drugs. What you won't find is any third-party advertising, corporate influence, or hype-driven, headline-grabbing stories with a lot of drama but no substance. You just get the real inside scoop on the health issues that matter to you most. So head over to chriskresser.com and check it out. And when you sign up for my email newsletter, you'll get instant access to my award-winning 63-page ebook, 9 Steps to Perfect Health. It's like an instruction manual for preventing and reversing disease and living a long and healthy life. Okay, now back to the show. Dr. Bredesen, thank you so much for joining me. I've really been looking forward to this.
And I as well. Thanks, Chris.
So we met at the Functional Forum event, and I was happy to have a chance to chat with you beforehand about your work with Alzheimer's disease, and was really excited to learn that you are beginning to approach it, or have been for some time now, from a functional and evolutionary perspective. So I want to spend our time together today talking about that. But before we do that, can you maybe just give us a 30-second idea of your background, where you're coming from, and how you got to this place where you're now looking at Alzheimer's from this perspective?
Yeah, thanks. So I've been a basic researcher for over 30 years. I came through Caltech and worked at MIT and also at UCSF. I worked for 2 Nobel laureates. And so we set up the lab 27 years ago now, specifically to answer the question, could we understand the fundamental nature of the neurodegenerative process in enough detail that we could fashion effective treatments? And we've been looking at that through transgenic mice and through cell culture models and Drosophila and all those sorts of things. But what was exciting is that just in the last 5 years, all of this research has converged on the mechanistics for cognitive decline in pre-Alzheimer's conditions such as MCI and SCI, and in Alzheimer's disease itself. And so for the first time, we can get a handle on what's actually going on mechanistically. And we've been very excited to see that we can make a difference. And we've got a couple of publications, one that just came out last week, actually, where we show for the first time that you can reverse the cognitive decline. And of course, there are caveats about getting in early and that sort of thing. But the surprise is that, to me, anyway, as someone who's in the lab, the surprise was that the lab work really converges very much on a functional medicine model. We didn't start out that way, but that's where it converged, really showing that when you look at what's driving the process, there really is a molecular switch that you see that has dozens of inputs to it. And you can see direct connections between things like estradiol level and copper to zinc ratios and HSCRP and all the sorts of things that we think about in functional medicine. So I was very excited to see that these things came together in such an interesting way.
Mm-hmm. So you really spent a lot of your career on the lab bench, looking at things on a micro level, and that led you to a more kind of macro approach where you're at least understanding all of those mechanisms within the context of this larger functional and evolutionary perspective.
Exactly.
Wow. Yeah, that is exciting. So I think with Alzheimer's disease, one of the biggest questions that is on people's minds is how much of this is actually in our control. We know that there's a strong genetic predisposition to Alzheimer's, but we also know that there is a strong contribution of environment because the rates of Alzheimer's disease have increased much more rapidly than any kinds of genetic changes could have occurred. So what's your take on the relative contribution of genes versus the epigenome and the environment in Alzheimer's etiology and pathogenesis?
I think that there is a tremendous amount that is under our control, much more than people have realized. And I say that because even with the genetics, as you know, you can impact with epigenetic changes. Mm-hmm. And for a simple example, ApoE, what's called epsilon 4 allele, so ApoE4, is the most important genetic risk factor. So if you have 0 copies of ApoE4, for example, if you're a 3-3, as is the most common, then your chance of getting Alzheimer's through your lifetime is about 9%. If you have a single copy of ApoE4, your chance is about 30%. If you have 2 copies, it's somewhere between 50 and 90%. So in other words, it's more likely that you'll get it than that you'll not get it. Mm-hmm. On the other hand, people with all 3 of these different genotypes have done very, very well on a functional medicine type of program. And so what we find is, of course, you want to get it started as early as possible, but you want to understand the drivers of the underlying process. So that this is a huge problem, as you know, in our country right now. For example, it's often pointed out that there are 5.2 million Americans who have Alzheimer's disease. But that's really somewhat of a misleading number because, of course, most people are too young to know that they're on their way to getting it yet. So what you really want to know is, out of the current about 320 million Americans, how many of us will develop it during our lifetime? And the answer is about 45 million people. So it's a huge problem. It has recently become the 3rd leading cause of death in the United States. And of course, it's a problem throughout the world. Mm-hmm. So the bottom line is there's a tremendous amount that can be done, and especially with prevention. And multiple groups are now reporting good effects with prevention. For example, Dr. Fotuhi out of Johns Hopkins, the large finger study out of Finland. These are all seeing the same sorts of things with a multi-component program. Mm-hmm. So I think that's what the biochemistry tells us to do. And for example, going back to ApoE4 for a moment, as you know, ApoE4 changes your lipid metabolism, changes your lipid absorption, changes your chance to activate an inflammatory process, changes the activation of NF-kappa B. All of these things are critical pieces of this, and yet they can all be addressed in a functional medicine approach.
Mm-hmm. So let me see if I can reframe that a little bit and tell me if you agree. So those statistics you shared regarding ApoE genotype and risk, they're pretty dramatic difference, between 9% and then all the way up to 50 to 90% for homozygous carriers of ApoE4. But we could say, maybe if we get even more specific, that those statistics apply to the population of people that have been studied who are following a standard American diet and lifestyle.
Exactly.
And I just want to point that out for the listeners, because I think what might happen is some people who are listening to this, who are following a nutrient-dense diet and, managing their stress and addressing any underlying causes, of health problems and pathologies, might think that those statistics apply to them. and get really freaked out. In fact, I've seen patients come to me, with their ApoE4, heterozygous or homozygous in tears, basically with the idea that it's written in stone that they're going to get Alzheimer's. And I go to great lengths to explain to them that those studies apply to a general population, and they are not really any longer part of that general population after they have made those changes.
Yeah, that's a very, very important point, that these are exactly the people that should be getting on a prevention strategy early. And they can do very, very well. In fact, we have people who've actually started down the cognitive decline, recovered on the program, and then stayed for years, sustained the improvement. Now, the longest our program has been around is just over 4 years. So we have people who have sustained their improvement for just over 4 years. We don't know how many more years it will be, but we do know that they've removed their risk, and we've removed the biochemical drivers, because these can be measured in the blood, so that we're very enthusiastic and optimistic about their remaining healthy for many years to come.
Yes, and that's, I just want to point out, far better prognosis than the vast majority of people who are diagnosed with this disease have.
Exactly.
Yeah. So I have a related question on genetics, and maybe I can separate this into two we can think about it in terms of two populations. So let's take someone who is already doing everything that we would recommend to prevent Alzheimer's. Solid diet, they're addressing underlying pathologies, they're working with a functional medicine practitioner. Do you recommend that somebody like that gets genetic testing, including ApoE4, but above, and I understand, there are other tests that can be used to roughly quantify disease risk. And then let's talk about another person who's not doing any of those things. So, the typical standard American diet and lifestyle person, is it worthwhile for them to get the testing?
Yeah, it's a very good point. And I actually think it's worthwhile for both to get the testing. So what we recommend is, as you know, when you're 50, you should get a colonoscopy. And we would say that when you're 45, you should get a cognoscopy. That's probably a poor term, but the idea is to get a cognitive assessment and to look at your biochemistry and genetics. It's relatively straightforward to do. And yes, you may already be doing many things correctly, but you want to be sure that your biochemistry is reflecting that. We are finding people who are doing things correctly, but for example, may have chronic inflammatory response syndrome, as you well know from Dr. Shoemaker, or may have, so we do find frequently people with high C4As, TGF beta 1s, low MSHs. We're more and more interested now in the rhinosinal microbiome. So, of course, there's been so much written about the gut microbiome, but if you look at what is the most direct route to the brain and to damaging the brain, in fact, it is through the nose, not the gut. Yes. And in fact, interestingly, the pathologists have told us for years, whatever causes Alzheimer's looks like it's coming in through the nose, because if you follow the pathology, it's really the rhinencephalon. It's really looks like there's some, quote, unknown pathogen that is causing this. And I think now we're understanding what these pathogens are better and better. And I'm sure you're aware of the study that just came out of Harvard last week showing that amyloid is actually antimicrobial. Yes. So no huge surprise. Yeah. We know that organisms liberate amyloid for 3 different reasons. And we've said actually for several years now that, in fact, what we call Alzheimer's is really a protective response to 3 different fundamental metabolic and toxic perturbations.
So I want to come back to that. I definitely want to go over those 3, but I want to first ask you, have you seen, I know one of those 3 is a mycotoxin mold type from reading your paper. Have you, regarding the sinus microbiome, have you seen a correlation between MARCoNS, multiple antibiotic resistant coagulase negative staph, for the listeners, which is a colonization of antibiotic resistant staphylococcus in the nasal cavity? Have you seen a correlation between that and those type 3 Alzheimer's patients that we'll talk about in a moment?
Yes, to the extent that we can say with a relatively small number of people. We've just had just over 100 people come through. then yes, we have seen that. But of course, I can't say statistically we don't have enough people yet that we can be very firm about that claim. What we do see, though, repeatedly is that people who present with what we've called type 3 Alzheimer's disease, typically more of a cortical presentation. They have things like dyscalculia, where they have trouble with simple calculations. They have trouble with serial sevens, subtracting 7 from 100 repeatedly. They have trouble with executive functions, organizing things. Those people virtually always have MARCONs, have some suggestion, high TGF betas, beta 1s, high C4As, low MSHs, very, very common. And typically they have the HLA-DRDQ haplotypes that were shown by Richie Shoemaker to be associated with SIRS. So they have the 4,353s and the 11,352Bs and things like that, or mycotoxin sensitive, or as you alluded to earlier, what about beyond mycotoxins? Yes, we definitely have some who are chronic Lyme patients.
Are you familiar with Dr. Susan Lynch's work at UCSF?
No.
I've read some of her papers. I think you'd be really interested. She studies the sinus microbiome, and she has argued that, big surprise, it's not so much the presence of a pathogen in the nasal cavity that is the problem, but it's the microbial diversity. So when you see lack of microbial diversity, that's when pathology occurs. And when the microbial diversity is strong, there can be the same pathogenic species present, but they're protected against by the beneficial microorganisms. And she found one microorganism called, which is Lactobacillus sakei, the one that you see used to make sake. And kimchi has a particularly protective effect. I know you've been at UCSF for many years, so I just thought you might be aware of her work.
It's interesting because it fits perfectly with, we've been talking basically about the exact same thing, because I've been in discussion recently with Dr. Thrasher and Dr. Dennis. Dr. Dennis is an ENT out of Atlanta who has spent years looking at chronic rhinosinusitis due to various mold species and has the same approach of trying to restore the normal flora as part of the approach. And again, we're seeing this as being a potential contributor repeatedly in people, especially with the type 3.
Yeah. So back regarding those types, we kind of let the cat out of the bag with one of them, but maybe you could tell us more about the other two and then, maybe summarize the third again.
Right. So as you know, there's been so much work on amyloid as being the, quote, cause of Alzheimer's disease. And in fact, a lot of pharmacological approaches to simply get rid of amyloid. Right. And what the problem is that you want to know really what is causing it. You don't want to get rid of it if it's going to be something protective. And now, of course, with the latest claim that it's also antimicrobial, now we're talking about, is it both damaging and it's also protective? So if you take a step back and ask, why do organisms actually make this stuff? As I said earlier, it really boils down to being a protective response to 3 different metabolic and toxic perturbations. So what we call type 1 is people who have ongoing infections or other causes for inflammation. So whether it's sterile inflammation or whether it's infection-related inflammation, that is type 1. And of course, you liberate the amyloid as part of an antimicrobial protective response. Type 2 is something that happens when you withdraw trophic support. So if you just take neurons in a dish and you withdraw their nerve growth factor, for example, or their brain-derived neurotrophic factors or other trophic support, they will produce amyloid as part of a programmatic downsizing. And that's type 2. And then there's something we call type 1.5, and here's why. If you have glycotoxicity, so you've got an insulin resistance state, as you know, and you've also got things like advanced glycation end products, then the problem is that you've got both an inflammatory induction through things like AGEs and also a trophic withdrawal response, because now insulin, which is one of the most important trophic supports for the brain, you're now resistant to that signal, that set of signals. And so you've got, unfortunately, a double whammy here of type 1 and type 2. So we call that type 1.5 because it gives a little of both, and it's actually a very common cause of MCI and ultimately Alzheimer's disease. And then type 3, as you mentioned earlier, is really what we see with a with a toxic exposure. And so, yes, if you actually have an infection related, then you can have some type 1 in there as well. But type 3 is when you typically have response to mycotoxins, to chronic Lyme, to other chronic infections. We sometimes see this with chronic viral infections, HSV1, things like that, where you're now responding to in a way that's really more like a SIRS type of response. And these people do tend to present differently. They need to be treated differently for optimal response.
So tell me a little more about your approach. Let's say someone comes into your clinic and, where do you start? Do you have a panel of tests that you do that begins to kind of organize them into one of these types? And then once you know their type, I imagine that directs the treatment plan.
Exactly. So what we think is most important, instead of just launching into a treatment without going without knowing where you're going, the idea is to look at as extensive a database as you can. So we want to know, and I should say this is similar to what others are doing with, whether you look at what Lee Hood is doing with Institute for Systems Biology, where they're looking very deeply at things like genomics and proteomics, or of course Craig Venter is now doing the same sorts of things down in La Jolla. And there are other groups doing these sorts of deep dives as well. The idea is that we want to increase the data set's size so that we can understand all the things that are driving the process. So right now, we don't have, if you compare to what's going on in oncology, people do the entire sequence, the genome sequence of the tumor and the host, and then compare them to look at what's actually driving the process. In degenerative disease, of course, we don't have a tumor to biopsy. So we collect right now just over 100 pieces of information that are historical, biochemical, genetic, imaging, and function. And then we put that into an algorithm that we developed, and we're working with a group in Silicon Valley led by Lance Kelly. And from there, it will generate for you the percentage contributions for the different subtypes, and then also an initial functional medicine type of plan. And of course, the physician can then decide to edit that, change depending on his or her background and interest. But this at least helps. This is essentially like having a physician's assistant. This is generating something that can get the program started. So we address many different things, from inflammatory things to metal homeostasis to hormonal optimization to SIRS-related effects, to toxins, to infections, so forth and so on. And I think, as you know, going forward, with the ability to look at neural exosomes that's been pioneered by Ed Getzel out of UCSF, we really have a better and better real-time view at what's actually going on in the brain through a blood sample.
Yeah, that is exciting. And as I know you're aware of this as well, the new genomic proteomic testing that Dr. Shoemaker is using to look at how gene expression changes in real time in response to treatment for SIRS is pretty exciting as well.
Very, yeah.
Yeah, and then I know you've also used, I believe, are using NeuroQuant in your diagnostic workup. Is that true?
At times. So we actually, I happen to like NeuroReader, because NeuroReader gives you 39 different brain regions and gives you a Z-score for each of the 39 different brain regions. NeuroQuant doesn't do nearly that many regions, but it does give you hippocampal volumetrics. So whatever you like whatever you choose, whatever you like to use, getting volumetrics on MRIs is so important.
And just for the listeners who aren't familiar with this is changes in the structure of the brain that can be caused by chronic inflammatory response syndrome, which we've now discussed on the podcast with Dr. Shoemaker twice, and I've written a couple of articles about that as well. So you go through this testing, which is comprehensive, and I'm constantly talking with other doctors in my training program and patients and anyone who will listen to me about the importance of doing extensive testing up front, and that it is a big expense, but my firm belief, and this is borne out by my experience, and I'm sure it is by yours as well, is that if you spend more up front, you often end up saving much more down the line because you get the information you need to make smart decisions.
Yeah, I couldn't agree more. As you say, you will save down the road, and not only that, you will then uncover what's actually driving the underlying process. And as you know, without understanding that, there's been great failure. And you could argue that the greatest area of biomedical failure is in the ability to reverse neurodegenerative conditions.
Right.
So without that, we've been very, very unsuccessful. Now, with it, it doesn't mean we're 100% successful, but it gives us a much better chance to improve. And again, we suggest to people come in early.
Yeah.
Don't wait. As you know, that's been a real problem. People will wait until it's very, very late.
Yeah. And we need to get this so deeply integrated that this is just the default. It becomes the default diet and lifestyle. And, who knows what's possible when people are following this kind of, well, actually, I think we do know to some extent what's possible when we study populations that have followed a traditional diet and lifestyle and who had at least some access to even emergency medical care. Diseases like Alzheimer's are remarkably rare in those populations.
Exactly. No, I think that there's a tremendous opportunity to reduce the global burden of dementia dramatically.
Mm-hmm. So once you go through the diagnostic workups and you start implementing these changes, where have you seen some of the biggest impacts in terms of diet, lifestyle, and functional medicine treatment with Alzheimer's? I imagine it depends on which type, 1, 2, or 3. But are there any particular things that stand out for you in terms of, the biggest changes that people can make?
Yes, and there are, and we've just, again, published on this on a couple of occasions where, for example, we have a person who's got their hippocampal volume going from 17th percentile to 75th percentile. So just dramatic improvements in hippocampal volume, dramatic improvements, quantitative neuropsych testing. We have one guy went from 3rd percentile to 84th percentile. People who are going back to work full time and doing very, very well. They notice the difference. Their spouses notice the difference, and the quantitative testing shows this difference. That this is not just a placebo effect. These are people who are actually having dramatic improvements. And yes, you really do, as you know well with a functional medicine approach, you really do have to live this. One of the things that I tell the people is, imagine you have a roof with 36 holes in it, because initially we identified 36 different contributors to this switch in the brain. Then having something that just covers one of the holes is not going to do you a lot of good. You really need to cover many of them, and that's when you can see these dramatic improvements. And so we do see it with people. As they move their metabolic parameters, so goes the cognition. We see people improving their HSCRPs. Simple example, we have a guy who came in with a HSCRP of 10, with a fasting insulin of 32, with a homocysteine of 15, with a BMI of 26. And all of these things improved. And interestingly, he didn't make them optimal, but he improved them dramatically. His fasting insulin fell to 8. His homocysteine fell to 8 also. His BMI actually came down to 24.5. All of these things, and just dramatic improvements. And he actually had an improvement in his hippocampal volume as well. Back at work, doing very, very well. So the metabolic contribution to this problem is huge. And I think it hasn't been quite appreciated enough that this is not just about a mysterious brain illness. This is a direct reflection of ongoing inflammation, ongoing metabolic changes, toxin exposures, and that sort of thing.
It's yet another disease of modern civilization.
Exactly.
Yeah. So if we step back and think about where the research on Alzheimer's has been, where it is now, and where it's going, what are the things that you're most excited about that are, in the next 10 to 15 years?
Yeah, I'm excited about a number of things. I'm excited about as I mentioned earlier, the neural exosomes, the ability to take a blood sample on any given day and tell you what is going on with your brain chemistry, your brain signal transduction, your brain trophic support, your brain ongoing infections, those sorts of things. Very, very powerful tool, and I think we're just seeing the tip of the iceberg on this. I think we'll see a lot more of this over the upcoming years. The second thing is the ability to look at the appropriate microbiomes, be they rhinocynal or be they GI, be they skin, other things that are going to contribute to this ongoing problem. And we're getting better and better look at what the innate immune system is doing. This really does overlap in a very interesting way with SIRS. The surprise to us has been these people often will have the laboratory values of SIRS, but will not have the history of SIRS. So they really don't quite fit the Shoemaker-defined paradigm for SIRS. And yet, there's something about the innate immune system that is activated in these people. And as I mentioned earlier, their HLA-DRDQs are ones that are, in fact, SIRS associated. So there's some very interesting hint there. And then I think that we're going to have better and better imaging techniques that will help us. And for example, there's retinal imaging that's going on, started initially by Keith Black and Steve Verduner, and they started a group called Neurovision, and I think this will be helpful as people do more and more of the retinal imaging. We'll be able, again, earlier and earlier. So one of the things I'm most enthusiastic about is now that you're looking at genetics, if you identify, for example, 7 million Americans are ApoE4 homozygotes, and we're working with a number of them. I hear from people fairly frequently who are in that category, have found it out either through 23andMe or through their physician or another method, and they want to get on preventive protocols. And I think that that's going to be one of the big areas for the future. We should make it so that we can prevent the vast majority of these people from ever suffering cognitive decline. So I'm very enthusiastic about that. I think that all these things are going to be very helpful. And then I think the idea of looking at, instead of testing a monotherapy drug, if you've really got a promising new potential therapeutic, let's test it on the background of the entire foundation. Let's close the other 35 holes, and now you close the 36, you can really see a big impact. So I think all these things, I have to say, as I mentioned, the lab has been going for 27 years now. I have never been, during that 27 years, as enthusiastic as I am now about the ability to reverse cognitive decline in neurodegenerative illness. And of course, ultimately, this will be part of Lewy body disease, Parkinson's disease, and other diseases, not just Alzheimer's and pre-Alzheimer's conditions.
And that is very exciting to me as well. To me, it's the convergence of the ancestral evolutionary approach, which, is the way that our bodies are hardwired to eat and live, combined with the incredible advances of modern medicine. And it's not, I think there's a mistaken assumption at times that people who are advocates of the evolutionary approach have a kind of regressive attitude and want to throw away all of the advances of modern medicine, which is not true at all. But we just want to couple that with a species-appropriate diet and lifestyle so we can harness those advances to the greatest possible effect.
Absolutely. I think that's a really good point. And, it really fits in beautifully with the whole ApoE4 theme, because if you go back to our common ancestor, 5 to 7 million years ago, when hominids first appeared, we descended from a group that had a different ApoE. ApoE4 began with the hominids 5 to 7 million years ago, and changed the structure of the ApoE, interestingly, and made it more pro-inflammatory. And so it has to do, as you know, with cardiovascular disease, with Alzheimer's risk, with the inflammation, and with evolution. And the question was, how can something which is supposed to be a fat bucket, supposed to be carrying around lipid, and that's supposed to be its only job, how does it have such broad-reaching effects? And what we found, and actually just published a few months ago, was really a surprise, that in fact, if you look at what ApoE4 does, it actually enters the nucleus and binds to the promoter regions of 1,700 different genes. So it's a little bit like finding out that your butcher, who's supposed to be the guy carrying around the fat, is also a senator who's also making the laws of the land. So you're really changing the entire program in your cells by the presence of ApoE4. And therefore, not so surprising that as we came down out of the trees and started walking along the savannah, and you probably know that Tuck Finch had suggested this a number of years ago, that what it was required for us to become hominids and to be walking on the savannah was a pro-inflammatory state, surprisingly, somewhat of antagonistic pleiotropy. It helped us as we were young, but then was a problem, of course, as we began to age. It allowed us, for example, to step on the dung that we were walking along. It allowed us to eat meat with raw meat with microbes in it.
Right.
Because you had this chronic pro-inflammatory state. So that was a good thing 5 to 7 million years ago. And it's only been in the last 220,000 years, so really only the last 4% of hominid evolution, that we've had ApoE3, which has now, of course, become the dominant one. And then ApoE2 just appeared about 80,000 years ago. So this, you're absolutely right. This was part of evolution.
And it's why I think it's so crucial to have this evolutionary perspective in any practice of medicine, because you begin to understand how evolution shapes our genes and our genetic expression. And without that understanding, we're really in the dark. We start to make assumptions that are not correct and can lead us in the wrong direction. LDL, for example, low density lipoprotein has some antimicrobial effects. So this idea that LDL, we should just get it to be zero, that the lower the better. If we got it down to zero, we'd be, better off. It's just completely ignores the important function that it had from an evolutionary perspective and still has today. But many of the changes that were protective in our traditional native environment are now problematic in this modern environment, and we haven't had time to adapt. And that's pretty much the whole evolutionary nutrition and lifestyle argument in a nutshell, isn't it?
Absolutely. And, you're right. People will come in, they're trying to drive their LDLs so low. We see this all the time where you have some atrophy and it's associated with having a very low cholesterol. And why? Because you're on a statin and you're preventing your cells from doing the thing that's actually appropriate. So you end up with a brain that has shrunken without the appropriate lipid content. So this is, to explain to people that, this is actually not good for your brain is not easy.
Yeah, it's because it's swimming upstream, it's going against the dominant paradigm. And that's why I was so excited to meet you and speak with you. You're someone who has a background in, conventional Alzheimer's research, who has shifted, through your own process of discovery, not from, reading a book on paleo or functional medicine per se, but just through your own thought process came to a functional and evolutionary perspective. And I kind of felt like this is how the change is going to happen. It's going to happen from, doctors such as yourself, pioneers who are in the trenches and who come to this conclusion through their own work with patients and begin to understand that this is the future of medicine and that the way that we've been doing it is not going to work, and who take matters into their own hands to push it forward. So thank you for being a pioneer in that world.
Thanks, Chris. Yeah, this is 21st century medicine. It's not monotherapies anymore. It's not trying to attack complex chronic illnesses with single drugs. It is looking at what is the actual cause, going physiologically and going upstream and going with multimodal approaches. If you had told me 10 years ago in the lab that we'd be telling people how important meditation is and yoga and nutrition, I would have laughed. And now I realize, you can't. The biochemistry is undeniable. You can just look at it and say, okay, this is why you have to drive your biochemistry to this point. And by the way, this is why you've got cognitive decline, because your biochemistry is not there yet.
Yes. So on this note, I'm curious, you've been doing this work for some time. You've shifted to this perspective. You've published a few papers on this perspective. Your center, it sounds like you've been doing this for 4 years now with patients. What has been the response in your field? I imagine it varies, but just tell us a little bit about what the range is.
Yeah, it's a good point. When we published the first article showing for the first time that you could actually reverse the cognitive decline, shortly thereafter, I went to a meeting at the NIH, and one of the NIH leaders approached me, and he said, "Dale, I read your paper. It's kind of weird." And so that was the initial response.
Yeah.
And there's been a lot of that. There's been a lot of, what are you guys doing?
Yeah.
As I was actually driving with Jeffrey Bland the other day, and I said, someone said to me, "Dale, what happened to you? You used to be a good scientist." And I said, "Yeah, I've gone over." to the side.
Right.
So the point is, this is the future, and looking at the mechanistics will drive ultimately everyone that way. But it's just going to take some time. Everybody wants to see a large trial. Now the paradox here is we started all of this way back in 2011, before the first patients came through. We proposed the first comprehensive trial for MCI, pre-Alzheimer's disease. This was to be done in Australia because we were including one group that had a drug that was available in Australia and not in the US. But this had all this comprehensive piece, both with and without the drug. So we thought this will be great. We'll be able to see how the whole protocol works with and without a new drug. And we had double-blind, placebo-controlled scans at the beginning and the end, all this sort of stuff. It would have been very nice. And the IRBs in Australia, both the public and the private, turned it down. And they said, this is too complicated. And they said, obviously you don't understand how to do a clinical trial because you're trying to change more than one variable. And we said, obviously you don't understand how Alzheimer's disease works because it's not a one variable disease. So just recently, a group in Sydney now has come back and said, well, maybe we can try to run this through again. Surprisingly, the very physicians who were on the IRBs that turned it down turned around and said to us, can we use it anyway in our own practices? So it's kind of a bizarre situation where we're so set up with this classic idea of doing single variable clinical trials. We've got to break out of that and look at the approach of multivariable trials.
Couldn't agree more. And this is, of course, one of the key principles of functional medicine, as all of my listeners know by now, is that it's personalized. And it's not single disease, single treatment. And this is what your model illustrates so beautifully is, you could have 3 different patients with the same disease label and they'll get 3 different treatments because the pathologies that are driving those diseases are different in each of those 3 patients. Same disease, but different pathologies, so you get a different treatment. And that's exactly why I called my training program ADAPT. It stands for Advanced Diagnostics and Personalized Treatment, because as any functional medicine clinician will tell you, you get people who come in and they've been diagnosed with the same disease, but they can present in a totally different way, and they need a different diet, they need different interventions across the board. And I think once we really shift into a mindset like that in medicine overall, that's when we're really going to see a whole new world of treatment possibilities open up.
Absolutely. So, Chris, let me ask you a question.
Sure.
How do we do N of 1 clinical trials?
That is a fascinating question. I don't know. It's something that's been on my mind for a long time. I have had some ideas I've talked with Mark Hyman about for how to structure functional medicine trials. I've been thinking about it for years because I was trained initially as an acupuncturist. And as you know, I'm sure in Chinese medicine and acupuncture, it's the same idea. You customize the treatment based on the person, which makes it very hard to study from a conventional allopathic paradigm because it doesn't lend itself well to that. But I'll have to get back to you on that one, Dr. Bredesen. Maybe we can get together and have a chat about it because it seems like a challenge just to design trials this way.
Yeah, what we've been thinking is that the old way of the trial was you say, okay, 100 people or 1,000 people, whatever, are going to come in and we're all going to treat all of them with blank, your drug X, and then we're going to have a placebo group. Great, makes sense. And instead of going after, here's a treatment, because as you said, it has to be different for each person depending on what is best for them. Maybe we go by not the same treatment for everybody, but to try to optimize each person's biochemistry. So we say, okay, we're going to drive everybody's homocysteine to 7 or below. We're going to drive everybody's HSCRP to less than 1. We're going to drive everybody's vitamin D to between 50 and 80. You go on and on and on like that. Then you have a way that you can actually have it in a kind of scientifically valid way, and yet it's not the same for each person.
I think that's a great way to approach it, and that's exactly what Mark Hyman and I were discussing. If you have targets that you can reach, and those targets have been shown in other studies to be associated with that particular condition, then you do have objective measurement, and it takes the variable of, oh, well, maybe this clinician didn't do, the right diagnosis or the right treatment out of the equation too, or at least minimizes that.
Right. Will you please tell the IRBs for us?
I don't know if they'll if that will help you, but I'll write a letter if you can help. Well, thank you so much for being here. I look forward to continuing to collaborate with you. And I again just want to thank you for having the courage to step out of this dominant paradigm. I mean, to be in that world for as many years as you were and still are, and to have the conviction to follow your own instincts, even if it takes you into the world of weird, as your colleague said. I don't think that's no small thing. I think a lot of people, even if they thought that was the right direction to go, might not do that because they'd be concerned about the effects that would have on their career. And I just applaud you for putting your patients first and doing what you know is right.
Thanks, Chris. You can't ignore the data. So great talking to you. And again, thanks for the discussion.
Take care.
All right, take care. Bye-bye.
That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at chriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/chriskresser or facebook.com/chriskresser L.Ac. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.